Hello and welcome to math for today. Okay, first of all, so we did not have a review because not everybody is done the morning math. So I'm actually going to give some dojo points right now for the people who are. So thank you very much. If you're not done it, you need to do that. Like stop watch the video and do it right now. And then you can come back and watch this later because we're doing a new lesson, but you need to have that done first. So people who are done, thank you so much. Let's see here. Ada, Alex, Ali, Amer, not Christelle, not DR, Daisy, yes, Daniel, Fassi, Ibrahim, Maddie, Malik, Matha, Mohammed. Cool, Mohammed. Did you change that? Quinn, no. Rajavi, I know you're working on it. So, yes. Rami, Rita, Ryan, no, not yet. Sammy, no. Soyun, yes. And Zaha, yes. So we're missing DR, Hisham, Sammy, Jordan, Ryan, Quinn, and Christelle. Okay, that's pretty good though. So you guys get math task done. Excellent work. Very, very, very good. Okay, so today we are doing a new lesson, okay? It is expanding upon what you did from yesterday, and I'll give you guys feedback on your stuff from yesterday as well. So here we go. Okay, new page. Theoretical probability. Okay, in today's date, June 9th. I can determine the theoretical probability of outcomes in an experiment. Okay, all right, here we go. So, So first of all, a little bit of background information. We have to, first of all, you can put this as like a term we have to know. Possible outcomes. Okay, this is important for understanding experimental probability. Okay, so we have to first of all be able to know what this means when they say possible outcomes. Okay, so a possible outcome is basically when playing a game or doing an experiment, there are usually a lot of possible outcomes. What could happen? So basically, it's how many options there are in total, okay? So if we're gonna fill this in, I'd like you to write down this little chart because you're definitely going to have some questions that kind of like are surrounding similar type things to this, okay? So, all right, what are the possible outcomes of flipping a coin? What are the possible outcomes? We have heads or tails, right? Heads or tails. So number of, I just put PO for possible outcomes. There are 2 possible outcomes, right? Heads or tails. Okay, rolling a 6-sided die. What are the possible outcomes? 1, 2, 3, 4, 5, 6, right? So how many possible outcomes are there in total? Well, there are 6, right? If we were rolling a dice that was like our blue ones in the classroom that are like, I think they're like 7 to 12, then the possible outcomes would be like 7 to 12 here. But how many possible outcomes would there be? Well, still 6, right? There's only 6 sides on the dice. If we had one of those cool like 10-sided dice, then what would it be? Then it would be 10 possible outcomes. Okay, let's keep going. So spinning the spinner. Okay, so here we have the spinner, okay? What are the possible outcomes? White, black, red, yellow, green, orange, blue, and purple, okay? You could write them all down, but that's fine. How many are there that I just listed? Well, the number of possible outcomes are 8. There are 8 possible outcomes, okay? Next one. Cards of a deck. Okay, do you know how many cards are in a deck? Without including the jokers, just like regular cards, so like all the face card or all of like the normal playing cards, there are 52 cards in a deck. I'm not gonna list them all. I guess we could. I'd say like ace, king, queen, jack, and then you have 10, 9, right? And so on, all the way to a 2, but then you'd have that I guess technically you'd have that times 4, right? Because there's 4 different suits. So we would say 52 cards in a deck, okay? Next one, if we had a bag which had 2 blue and 3 red chips. Okay, well, what would be the possible outcomes for this? This is a little bit different. Well, there's actually only how many possible outcomes are there? Okay, well, there's really only blue or red, right? Even though there's 5 chips, but how many possible outcomes would I be able to select from? In this case, there's only 2 possible outcomes, right? Regardless, I could have said this is 12. I could have said this is 32 or 33. It's still only 2 possible outcomes, okay? I hope that kind of makes sense. Okay, just as like our first introduction. Okay, now, the next thing is this. Okay, theoretical probability. Alrighty, so this is super important to write down, but let's just write down a couple other things first. So you should have a new subheading underlined, right? Theoretical probability. Okay, you could even put like a colored box around this or something to make this stand out. Theoretical probability. Okay, so, or, yeah, okay, I'd probably say highlight this actually. Okay, so theoretical probability is the likelihood that an event will occur. So in theory, right, that's the root word of theoretical. So in theory, how many times would we expect this event to occur, right? How many times do we think that this should happen if it was like a perfect world? So there we go. In a perfect world, this is what we expect or predict will happen, okay? It doesn't mean that it is going to happen. In fact, it's not that. If you think that it like is definitely what happened, yeah, that's not really the right definition. The definition is, in a perfect world, this is what we expect or predict will happen. So this is the formula, and you guys will see this a bit more as we kind of work through it. So the formula is, and I suggest again you put this in like a bright box so it really stands out. Theoretical probability is the number of favorable outcomes. This is kind of what we want to happen. Maybe like you're gonna win a prize if you draw an ace out of a deck of cards, for example. So how many aces would there be in the deck of cards? Well, there's 4. Okay, that's the number that's favorable to you out of the number of possible outcomes, which is what we did on the last page. So the number of possible outcomes, if it was the deck of card example, would be 52, right? 52 cards in a deck. A different example. Okay, let's go through another one. Okay, so what is the, I'd like you to write this one down. What is the likelihood of rolling a 3 on a 6-sided dice? Okay, what would be the theoretical probability? So I put TP, you might see that come up. TP means theoretical probability, okay? So, all right, and we're gonna write our answers using fractions. So the number of possible outcomes. Okay, you might need to pause me because I know there's a lot that I've had you write down, so maybe you need to do that. I'm just gonna keep going though. Okay, so the number of, okay, we have to set this up as a fraction. Okay, so, alrighty, as a fraction. Okay, so how many, let's see, I'm gonna roll a 3 on a 6-sided dice. Okay, well, first of all, the number of possible outcomes. How many possible outcomes are there on a 6-sided dice? There are 6, right? Now, if I win, or this is the likelihood, I'm only wanting to know a 3. So the number of favorable outcomes. Well, how many 3s are there on a 6-sided dice? There's only 1. So my theoretical probability of rolling a 3 is 1 out of 6. Or out of every 6 times that I roll it, I would expect to get a 3 only 1 time. Okay, that's what theoretical probability, that is the theoretical probability. Okay, the next one, number 2. What is the theoretical probability of rolling an even number? Okay, I should have said on a 6-sided dice, because we're using the same 6-sided dice. Okay, so for this one, all right, well, how many possible outcomes? What's the number of possible outcomes? Again, on a 6-sided dice, that hasn't changed. There's still 6 possible outcomes, right? Now we have to think about this a little bit further, okay? Usually it's the numerator, the favorable outcomes, which you have to actually think about harder. The possible outcomes should be pretty easy to come up with, just like how many options are there in total. Okay, now rolling an even number. Well, how many even numbers are there on a 6-sided dice? 2, 4, and 6, right? I'm happy days if I've rolled any of these numbers. So how many, what is the number of favorable outcomes? Well, there are 1, 2, 3 favorable outcomes. So my theoretical probability is 3/6, or going back to our fractions unit, equivalent fraction is 1/2, right? Our magic number would be 3, right? We would have divided both by 3, not minus, divide both by 3, right? 1 divided by 3, 3 divided by 3 is 1, right? 6 divided by 3 is 2. So there you go. That is it. Okay, that's all you need to know for today. I guess if we did a couple more, say that we wanted to know the theoretical probability of tossing a heads, then it would be 1/2, right? Say we want to know the theoretical probability of rolling a black or spinning a black on this spinner, it would be 1/8, okay? Or what if it was spinning white or black? Well, favorable outcomes, white or black, 2 favorable outcomes out of 8. So 2/8 or 1/4. Okay, this is your homework. It is page 273 to 274, questions 3 to 7. Okay, so that's this. I guess I just didn't have you do the first couple. Okay, fine. I guess you could actually. Should we do that? One, yeah, let's do them. Yep. Sorry. 1 to 7. Okay. 1 to 7. Okay. It's not hard though. You'll see. Just a little bit of good practice. So a paper bag contains 2 green tiles, 4 yellow tiles, and 1 blue tile. Liz draws a tile without looking. List the possible outcomes. Okay, so how many possible outcomes are there? Green, yellow, and blue. So there are 3 possible outcomes. What is the theoretical probability of selecting a tile that is green? Okay, well, it would be 2 out of how many total outcomes are there? There are a total of, let's see, we have to count up how many things there are in total for this one. There would be, oh yeah, okay, so for this one, yeah, okay, so you do have to count them all up for these ones where there's like chips in a bag. So there are 2, 4, so 6, 7. So for green, it would be 2/7. Whoa, right? Whoops, I don't want to do that. No, I don't want to do that. Okay, anyway, I'm just going to close this. Okay, so 2/7. And then this one for, no, close. I don't want that. Okay, maybe it's this one. No, that's not it either. Okay, anyway, for yellow, then it would be yellow. It would be 4. That's not what I want to do. Sorry. It would be 4/7. Okay, and then blue would be 1/7. Okay. And then this one, again, you have to add up the number of total outcomes. And then, yeah. And then I guess this one would be, okay, the student whose name will be drawn first to be present for his or her speech. What is the theoretical probability the girl will present first? Okay, so you have to add this up. So 13 plus 17 is 30. So then it would be 13/30. Okay, that's the chance of it being a girl. Okay, and then here are some other ones. So you have to do all of these ones all the way down to, what did I say? Question number 7 or 8? Yeah, question number 7. So you end with question number 7. Okay, that is it. Good luck and see you soon.